recently just finished your developing strength and power course that you can purchase online through Latrobe, and talking a little bit off air just before about the value of the industry being on the same page and having alignment with communication. But where did those sort of 5 strength qualities come about?
Most of my research questions that come out of personal experience. Early in my PhD, you're managing counter movement jump data and load and jump squat data. And you're pulling out these dozens of metrics and you're like, well, which ones do I choose? When I moved to Ballarat and worked with Warren Young there, his PhD actually solved this problem and looked at strength qualities and managing all these metrics and then kind of boiling them down into a couple of distinct factors or domains. And you do that by principal component analysis or factor analysis, even just simply running some correlations, right? To see, okay, which variables are all tightly correlated? We're going to put them as a cluster over here. Which clusters of variables are different from that? You put them over there, and you can kind of essentially make a decision on which one of those variables from within the domain you'd like to bring forward and move into your model. And that was kind of the framework or the genesis to getting towards this 5-factor model of strength expression.
In maximal dynamic strength and fast strength seem to be particularly important with athletes. Can you explain why these qualities are so critical in sports performance, and ultimately for the coaches listening in, how should we train specifically to target them?
I guess probably an important point to get to before we get to that point is, what are these five different domains? We've got your maximal isometric strength, then you've got explosive strength, and then you've got heavy slow strength, which is just your lifting strength, maximal dynamic strength, fast strength. And then finally, we've got something like reactive strength, where you've got a really fast stress shortening cycle action that occurs. So you have those 5 roughly different domains. And then the question is, all right, so does heavy dynamic strength, so your lifting strength, seems to rise to the top because perhaps one, it reflects the ability to apply force against heavy loads, which is important in collision sports, but also it transfers across domains. So for example, if you're relatively weak, let's say if your 1 RM back squats less than 1.5 times your body mass, you'll certainly get increased maximal power. So measures derived from, say, a counter movement jump, you'll get benefits in that domain as well. Measures derived from a counter movement jump seem to be particularly important because it has sort of a sports specific movement velocity. So that's perhaps why it's risen to the top in the literature. But also, they've always been easy to assess. Again, you need to look at your own sport, your own context, and then build a performance model to see where the associations are between the different strength domains and the key aspects of your sport.
Have you seen a specific environment or spoken to people in the industry using these 5 at a really high level, and that differ to the isometric max strength and then the explosive strength as well? I think would be interesting to dive into, because perhaps they're not as popularly used methods as the heavy dynamic strength.
Yeah, really good question. So I only put the paper out, it might have been 2 years ago, with the goal of simplifying strength measurement systems for everybody. A national institute networks like the QAS, they're looking at using those 5 domains to inform sort of monitoring and tracking strength quality. So in the second part of your question was talking about isometric strength and heavy dynamic strength and how they're employed and sort of the understanding of that. So this is an interesting one to unpack. We're talking about here maximal isometric strength, so a peak force derived from mid-thigh puller iso squat, and with respect to your lifting strength, so 135 RM, and then the associated training underpinning that. So people use them interchangeably in practice, but also to very different forms of force expression. So you look at the cross-sectional correlation, and so it's roughly around 0.7 or so, right? Which is about 50% shared variance, generally speaking, in non-weightlifters. That means you've got 50% of the performance unexplained, right? Which means very different based on the data with over 100 participants in that meta-analysis, 100 points. And it showed that the relationship between a change in peak isometric force versus a change in 135 RM of the respective dynamic version of that test was essentially 0. So what do? You need to train them and assess them differently.
What are some of its contributions towards athletic performance when developing reactive strength? What are some of the results that we could expect to see or for their on-field performance?
So reactive strength is a bit of a colloquial term. It maybe isn't the best term, but it's been using it for decades to describe a fast stretch shortening cycle action. Drop jump, for example, to be quick off the ground and then high as they can go. And you want contact times less than 250 milliseconds. These mechanical similarities to high speed running, which is where you can see some pretty good transfer there. Also, jumps off single legs. So you're looking at things like triple jump, high jump, long jump. If you start training for ballistic tasks like a counter movement jump or a squat jump, where the cue is to only maximize height and there's no cue for contact time or movement time, then you're not going to see much transfer to reactive strength.
What do you think are some common mistakes or pitfalls to avoid for practitioners that are looking to incorporate these 5 strength qualities in their programming for the upcoming seasons?
If I had to be really specific and say one thing, which I've done too, and it's easy to do, is you're probably choosing too many counter movement jump metrics. Probably the biggest general mistake. You can explain the counter movement jump in like 2 or 3 metrics. So something that represents how high they go. So something an output type measure, something that represents the duration of the movement. Okay, like time to take off or movement time or contraction time. It's probably the common error is because there's so many metrics that are available, you end up choosing half a dozen to represent a counter movement jump. And now you've still got 4 other qualities that need to be described, but there's only so much space on a report. And more importantly, there's only so much cognitive space for the end user when they're looking at these numbers.